This is wastewater treatment certification, Chapter 9, Pumps and Motors. Pumps are a machine that imparts energy to a fluid, causing it to flow, rise to a higher level, or both. Acceleration of water, the change of velocity over time, is caused by rotation of pumps' mechanical energy being converted into hydraulic energy, pressure. There's kind of a schematic of a pump. Water is pulled into the eye, or pushed into the eye actually, and as the water travels around through the impeller, it's thrown to the outer side of the impeller where it increases speed and literally gets thrown up the discharge side of the pipe. Pumps can be categorized by the character of material they handle, like raw wastewater pump, grit pump, effluent, return activated sludge, waste activated sludge, raw sludge, anything like that. They can be categorized by the pump function, a high lift pump, a low lift pump, recirculation or high capacity, or the principle of the pump's operation, centrifugal, propeller, reciprocating, incline screw, progressive cavity, or pneumatic injector. Centrifugal pumps are the pumps that are used mostly in the water and wastewater industry. It consists of an impeller rotating in a case. The impeller is on a shaft supported by bearings. Liquid enters the center of the impeller and it's thrown to the discharge by the speed it picks up through the impeller. And typically these pumps have a large opening at the center of the impeller to prevent clogging, even though we all know what the disposable wipes do to them, don't we? Here's a picture of a centrifugal pump showing how it works. The volute is the housing. The impeller is the most important part of the pump. If you notice you're seeing a drop in the amount of water your pump is pumping, before you think you need a new pump, check the impeller. Impellers can go bad. Pump parts, you've got shaft sleeves. These are used to cover the shaft that supports the impeller to protect the shaft from the corrosive and abrasive effects of the liquid going through the pump. Wearing rings, these are used to plug the space between the impeller and the casing to prevent internal liquid leakage. The rings are either attached to the casing, the impeller, or both. Check for wear regularly and replace as needed. They're called wearing rings because they're made to wear out, so you replace them to protect your pump. Water is the lubricant between the rings and the impeller, so pumps should never be allowed to run dry. The stuffing box is used to prevent air from being sucked into the pump. It consists of a casing containing rings of packing and a gland or membrane at the outside end. Water is used in the stuffing box to block out the intake of air and to lubricate the packing. There's your packing is the orange rings you see in the pump. The green is your shaft. You can see the lantern rings there too above the shaft. We're going to talk about them in just a minute. The stuffing box is water connection, since it uses water as the lubricant to prevent a cross connection. The connection with the potable water supply line must include an air gap separation or an approved backflow preventer. Nobody wants wastewater in their drinking water. Excessive leakage is an indicator the packing needs to be replaced. The packing material may be graphite, asbestos, Teflon, or other braided material. You replace the packing when it loses its flexibility. When hardened, it loses its ability to seal the stuffing box. There's the lantern rings we were talking about. Lantern rings provide a water seal connection between the water supply line and the stuffing box. The rings are a perforated plastic or metal ring that surrounds the shaft. If the packing is adjusted properly, there is an even flow of water for proper lubrication. Pump efficiency of centrifugal pumps. The pumps start at 0 when they're shut off and then increases rapidly until a peak is reached at approximately the midpoint of the overall capacity range of the pump. That's why if you need to pump 400 gallons a minute, you don't buy a 400 gallon per minute pump. You buy a 600 or 800 gallon per minute pump, so the pump's running at about the midpoint. The pump should be selected so that the range of operation is at the midpoint or the best efficiency point of the total pump curve. Propeller pumps, there's some pictures of them. Propeller pump types. Axial flow type have a flow parallel to the axis of the impeller. Mixed flow have a flow that is both axial and radial or perpendicular to the shaft, to the impeller. Here's an axial flow pump. See, the water is flowing along the shaft that's got the propeller on it. It's pulling the water in and forcing it out. Axial flow pumps are not used typically to pump raw wastewater. They can be used for wet well applications. They normally have a vertical shaft with a bottom suction. The propeller is at the bottom of the shaft in a bowl. The propeller stays totally submerged. They have a capability of between 1 to 40 feet of total dynamic head. That's how high they can lift the water. Mixed flow pumps. There's one there. Kind of looks like a centrifugal pump. Mixed flow pumps are used for wide, unobstructed passages. They're the intermediate between radial and axial pumps. They're normally used in dry well applications. They have horizontal or vertical shafts and operate between 10 and 60 feet of total dynamic head. Reciprocating or piston pumps. These pump by moving a piston back and forth. These are normally what your sludge pumps are. With this pump, you never want to pump against a closed valve, because if you do, it will cause damage to the pump or the piping. It's a reciprocating positive displacement pump. There's a picture of one. As the pistons go back and forth, when one is pumping, the other is opening to allow more stuff to go in to be pumped. Inline screw pumps. These are auger type pumps housed in a trough on an incline. They're supported by bearings on the ends. They're commonly used on influent and effluent. They're low lift, high capacity pumps with a pumping range of 100 to 70,000 gallons a minute. There's a picture of an incline screw pump. A few places in Kentucky still have them, still use them. You have progressive cavity pumps. They're similar to incline screw pumps. The rotor is encased in a housing called a stator. The size of the cavities in the rotor and in the stator determine the pump's capacity. Again, with these, never pump against a closed valve. There's a progressive cavity pump. You see the grooves cut in the shaft there. That's what dictates its capacity. Pneumatic ejectors or airlift pumps. They consist of a receiving chamber inlet and outlet, check valves, an air supply, and a liquid level detector. When wastewater reaches a preset level in the receiving chamber, air forced in, ejecting the raw wastewater. The pumping range is between 30 to 150 gallons a minute. Airlift pumps work on the principle of a decrease in overall specific weight of a confined column of gas and water mixture. So as it pumps that air in, the air bubbles coming up push the water out with it. As wastewater reaches the preset level, air is forced in, ejecting the raw wastewater. And as I said, they pump between 30 and 150 gallons a minute. There's a picture of a pneumatic airlift. Water comes into that chamber there. When it gets to a certain height, air will inject into that section and force the water out. Pump motor maintenance. Before you work on any pump motor, make sure you check for locked out, tag out. Make sure all forms of energy are locked out and disconnected. That's not just electricity, but hydraulic, air, anything that can cause somebody to get hurt. When you're checking the motor, look for dust, dirt, moisture, obstructions in the air circulation vents, and excessive leakage of grease from the bearings. When the pump is running, check for noise, excessive heat, vibration, intermittent to continuous sparking of brushes, or sluggish operation. You check for bearing whines, gratings, and uneven noises. You can use a stethoscope for this or a screwdriver. You want to keep a close watch on amperages being pulled by the motors. An increase could be indicative of a pumping restriction or clog. A decrease may be a result of a break in the discharge line. On three-phase electrical motors, periodically check the motors wound for three-phase current to ensure equal distribution across all three phases. If one phase cuts out while in operation, the motor may overheat and become damaged unless it's stopped by a thermal control device. Operating issues: if the pump won't start or run, check for blown fuses or tripped circuit breakers, breaker contacts that are corroded or shorted out, terminal connections that are loose or broken. Check the automatic control mechanism, make sure check and see if it's functioning or not. Make sure it's set properly. If the pump's supposed to be set in automatic and somebody's got it set into the off position, it won't run. Check to see if the motor is shorted out or burnt out. Check to see if the thermal units are too warm to allow operation. If you're having reduced pump discharge rates, check to see if the pump is primed. Make sure you're not getting a mixture of air in the wastewater. The speed of the motor could be too low. You could have improper wiring. There might be a defective motor or a damaged impeller. Maybe the discharge head's too high. There's one of those nice pumps you see in the picture with the big opening in the middle, but there's what those wipes will do to that pump every time. Make sure the suction lift is not higher than you anticipated. Make sure the impeller is not clogged. The discharge line could be clogged. If the pump was recently put back in service, make sure it's rotating the proper direction. Make sure there's no air leaks in the suction line or the packing box. Your inlet to suction may be too high, allowing air to enter the pump. The valves could be partially or entirely closed. Check valves could be stuck or clogged. And the impeller adjustment could be off, or if the impeller was recently replaced, they may have put the wrong size impeller in. Make sure the impeller's adjusted correctly. Check the impeller for damage and see if it's worn. Check to see if your packing is worn or defective. Make sure the impeller is not turning on the shaft because of a broken key. A flexible coupling could be broken to the pump. Belts could be slipping, or your wearing rings could be worn. Causes for high power requirements. The speed of rotation of the pump is too high. You're pumping with check valves that remain open. The specific gravity or viscosity of the liquid being pumped is too high for the pump. You don't use the same pump for molasses as you would for water. Make sure the pump's not clogged. Make sure the sheaves on the belt are properly aligned. Check the pump shaft, it could be bent. You could have rotating elements in the pump binding against the housing. The packing could be too tight. The impeller could be rubbing the volute. Operating heads are lower than the pump is rated for, resulting in excessive pumping rates. For noisy pump operation, maybe your pump is not completely primed. Maybe the inlet's clogged. The inlet's not submerged, so you're pulling air. The pump is not lubricated properly. You're trying to pump with that impeller in the picture that's worn out. The foundation's insecure. There's strain on the pump caused by unsupported piping fastened to the pump. If you've got piping coming off a pump, that piping needs to be supported. There could be mechanical defects in the pump. Could be a misalignment of motor and pumps where connected by a flexible shaft. There could be rags or sticks wrapped around the impeller. And it could be caused by cavitation. Let's watch this video.
Here we have a pump trainer. We have an electric motor with a horsepower meter. through a magnetic coupling through a centrifugal pump. The pump itself is made of acrylic, so we can see the spinning impeller inside. We can also see the fluid go through. It's got a gate valve here in the discharge. It's got another valve over here on the suction. And all the piping here is clear, so we can watch the flow of fluid. Right now, it's all clear water, so we can't see much in that regard. It's got a road meter here showing us the amount of flow. What I'm going to demonstrate here is cavitation. We're going to purposely cause cavitation to occur in the system. We're going to do so by keeping the discharge valve wide open like it is and pinching off the suction valve. What that will do is reduce the pressure of this line, and you'll see this compound gauge show a stronger and stronger vacuum as we begin to pinch off this valve. Now start to turn this clockwise, and you'll see the gauge's indication go down. You'll also begin to hear cavitation take effect. We'll be able to see the bubbles form inside of here as it cavitates after it flashes in the vapor and cavitates into liquid again here. So here we go, closing the valve. And watching the gauge. Gauge will go down. Minus 10 inches of mercury. Minus 12. Minus 14. You can start to hear flashing occur there. 16. More noise. Minus 18. Minus 20. You start to hear that sound. That sounds almost like rocks going through the pipe. There's no debris. There's no solid material through here. That solid sounding sound is really the collapsing of the vapor bubbles as they go back to the liquid form. You can really hear it now. You can see it occur inside of here. It's a very pronounced action and noise. As the water goes through the valve, it reduces pressure going through the restricted valve. Its pressure drops below the vapor point of the water at this temperature. It flashes into steam, and then after it comes out of the valve and expands again, the pressure goes up, and what happens is those vapor bubbles collapse back into liquid, and that's where you get the cavitation effect. You can see it happening here. We can also see some bubbles here in the scroll casing of the pump. Cavitation is very destructive, especially upon metal surfaces. The acrylic surfaces here seem to handle it a little bit better, but with metal surfaces that don't give, and very destructive. The metal becomes pitted by the high pressure jets formed by the collapsing bubbles. So I just want to illustrate what cavitation looks like in an acrylic tube and what it sounds like. Sounds like rocks, literally like rocks going through the pipe. And again, we cause it by dropping too low of a pressure, causing flashes to occur, and when the pressure rises again, the bubbles collapse, and that's where cavitation occurs. I will open this valve back up. That increases the pressure on the suction side of the pump, less and less vacuum, until we no longer flash, and we no longer cavitate. And that's a happy pump.
Cavitation, like he said, is very destructive to pumps and impellers. I've actually seen the volute of a centrifugal pump be blown apart from cavitation, from the collapsing of those air bubbles that are formed. It's amazing what air bubbles will do. And that's the end of Pumps and Motors in Chapter 9. If you have any questions, you send an email to envhelp@ky.gov, or you can call 502-782-6189 and leave your message. They will, or your problem, they will be forwarded to a trainer who will get back in touch with you and talk to you about your problem.